Hello. We're back for more mini cast. Let's see what was happening. We were trying to make this example of what I plan to transpile my generics into. Hello, I borrow check. By the way, quick. All right. So we plan to transpile cast to minicast, and we plan to transpile generics into the existentialized functions where they actually take reference to any type, but we have the type info present at the runtime. The alternate universe PewDiePie from this angle. All right. So yeah, this is what we do. And then I was doing some things. Let's see if we do cast mini compile. So now we need to compile not only this code, but also like the runtime. There's a little bit of the runtime, which specifies the type information and like how to do things. All right, and then there is still some things that I need to do. For example, the equality operator, right? So over here, t kind is object. Yes, we need equality operator, and it only will work for the enums, I think, for now, at least. I'm not sure if the minicast will support the general purpose operators. Yeah, not. It will not. Okay, so I need to do this thing. This is in the mini compiler over here. All right. I borrow check is here. Let's take a look here. I have a function I borrow check, which is it seems like 700 lines long, right? I think I should actually like extract it. This would make sense to extract it. We just like have all of the expressions in the language like embedded here, right? If we're trying to parse their type info, then this is like over here, but this should be you know, like extract into a separate function, I suppose would make sense. Hmm. But we don't care about this right now. It's okay. We just add to this pile. Let's say if rule name is equal to something. The equality operator. It's just called equality operator, like this. In this case, we have the left-hand side and right-hand side. We expect two children with no names. Left-hand side, right-hand side. The type of this is going to be Boolean. And this is an expression. And what is the expression that we will have? Do I have it right now? So since this is like dedicated for comparing the enum, like, yeah, maybe like I will actually have like a switch for the enums, because switch can be compiled more efficiently into like the jump table or whatever, right? Instead of having the if then else chain. But we'll do that later. think. Let's just do the enum is, right? So we have the enum, which is expression. Right, and variant is a string, right? So is the enum this specific variant? That's what we want in this case, right? This is the enum t kind, and this is the variant is object. Right. So we return enum is enum variant. Okay. So variant is right hand side expect identifier, right? And left hand side is parse expression. We don't know the type of it. We don't know the type of it, so it's just parse expression left hand side. This is the enum, right? But we need to check that this variant exists in the type of the enum. So now after we parse this expression, we know the type of it, right? Enum type is enum type. We need to match result type aliases of the enum type with if this is the named name enum variants, right? If it's enum name, then we'll say that definition is context programs, program types, map get name option on wrap, and then we return a match definition with it must be the enum variant. Then I just return the variant. Right, but if it's anything else, then we should do the error here. And in this case also it is the error, right? Let's do our here return variance. Nothing here and nothing here, right? Because I want basically say over here with return, we're going to do this, and over here we do the diagnostic, saying that we expected expected a variant type got print type name of the enum type, and this is the left hand side span, right? That's where we show the error. Okay, so now we know the variant, we know the enum variants, and we also will say that if not variant contains variant, then I'm actually wondering if the pipe operator is the correct priority. Is this supposed to parse, or is it not supposed to parse? Like, what do we want this to be, actually? Right? In the source syntax. In the std syntax, right, over here. The pipe has priority of 14.5, and the end has less priority, so and not has less priority. Like, so actually this is going to be like, I don't need parentheses here, which is what we want. Okay. Yeah. Would you want this to be the other way? Probably not. I need to like make the LSP feature where we don't need to like look into the thing. We need to instead understand the parentheses like using the editor. At some point, we'll go back to working on the LSP. So if it does not contain the variant, then I need another diagnostic, saying the error, right? This is not correct. This variant does not exist in type, and we print the type of the enum, right? And the span is going to be the right-hand side span. Okay, actually the right-hand side is not supposed to be the identifier, I think, right? It's supposed to be. Yes, it's supposed to be is the helpers expects to be the rule, which is the variant, right? And then we expect single child with no name, I think. I mean, let's take a look at the mini syntax again. Right, it's a variant which has a child. It's called label actually, right? Because we are getting the label. And label must be the identifier. There you go. Let's try building. You've been thinking. No way. What have you been thinking about? Well, Kaplan plus experiment could not find variance in scope, right? Because it's not variance, it's like enum variance, right? That's what I called it. Should we go into the 6080s? Let X. What's 6080s? Let X and if X for binding equality. Very same thing. All 60s language did before BC, and into colonics for assignments like Algol and many others did. Sure. You know what I was like thinking about? Also, like sometimes I think about the syntax, but you know, like I feel like the specific choice of keywords it like matter. It's like doesn't matter too much, but the thing that like to avoid the disgusting equal. Yeah. Well, I mean, yeah, people are basically like used to it, so yeah, I don't think it's a big problem myself. But yeah, I guess it is disgusting maybe. Sure. But yeah, we were saying about like the left hand side left arrow. So like you know like you have like place and you put the value into the place like this, right? That's what you do already in OCaml in some places where mutation is involved at least, right? But the thing that it doesn't like really matter. The thing that matters more, in my opinion, is the order of things. And sometimes you want basically the to change the order of the expressions, right? So sometimes I feel like you want to calculate the value and only then specify the place where you want to put it, right? And this is why the arrows is technically making it more consistent. The only like problem is that this arrow is already being used for function declarations, and this like you know the arrow looks the same, but being in the opposite direction means completely different thing, which means that it's also not consistent, in my opinion. You know. You want plus equal and this equal, yeah, but I feel like there could be a different syntax, you know. You can say like place, you know, like so like you want to say like plus value, right? But what if you like you allow on the right hand side a specific thing which already refers to this place, you know? What if you say like, you know, this plus value, or like because this is more generic, right? What if you want to square the place, right? What if you want to say this is this times this, you know? You know, and this could be something very short. Maybe you literally just say the dollar here or whatever, you know, because like, do you want a dedicated operator for like squaring the value? Probably not, right? So you know, you're for some reason like trying to get away from the equal sign, meaning the assignment in most languages, but you still want for some reason to go to the plus equal, while there are other alternatives to the plus equal operator. You know, that's what I'm saying. You can use the arrow, and then you can use like this plus 2, and this is going to be placed plus equal to in other languages. Is it that bad? Like I say, this is more flexible because you can use any expression here now, right? It is same to you know, like how some languages allow you when indexing, you know, you have like array and then you index, you know, like I do it sometimes. What how do you index the last element in the array? You say like array length -1 or whatever, right? Isn't this very verbose, and like, and you also duplicate this thing? So some languages actually allow you to do the dollar here, and dollar inside of the indexing operators basically means the length of the current thing. It's kind of the same. Right. I'm not doing this yet, but yeah, sometimes it's nice to think about these things. I think that syntax, even although it matters, it doesn't matter that as much as the semantics of the language. So it's whatever. And I can change the syntax in the future. I have already changed the syntax multiple times, so yeah. All right, I'm working on the mini cast here. Is your language working already or not? What are you compiling to? Are you going straight for LLVM? I don't remember what you're doing. You're working on everything but runtime now. Runtime redo is missing. VM is missing. So you have the VM. You're not compiling to native code. You're compiling to bytecode and then running through the VM. Wait, ort set contains. Oh, I have a reference and I have a reference to a reference. Oh, because in Amveris is already a reference, right? Okay. I'm trying to get a reference to a reference. Okay. Cast mini compile. Okay, now the tuple doesn't have that field type. Type. What is this? In the type info? Where? Type info. Is that what I'm doing? No, type info has the type. Hold on. And the 60s use have let x versus x context difference. Yeah, whatever. Wow. Well, I mean, looking at how people were doing things and how other people are doing things is good, but like, I don't know. Everyone, like, it's not consistent anywhere, in my opinion. So might as well just use the most popular thing, which is mostly used in the current state of the world. Sometimes, even although like the equal equal is ugly, it's okay. So that's why I use the equal equal. Maybe I can like catch a panic here or something. I have like a panic somewhere, and I don't have like the pointing into the expression, and I don't have like the stack trace either. Um, I don't have the cast stack trace. Um, well, I'm trying to like get the thing called type, right? Tuple doesn't have the field type. You know what we should do? You know, it is in the ASD helpers, right? Because we are trying to, yes, we are trying to like get named type, right? And this over here, this panics, right? If we don't have that name, basically. So maybe what we should do, right? Like over here, I'm doing the better diagnostic, and I'm giving you the span too. AST group. Wait, do I have the spans in the AST groups? That would be nice if I had them. I do have a span in the group. Oh, that is great. Okay. So I can actually like report the error properly. Right? Yes. So I want to like say something like, and this one, right? Yeah. I want to catch panic with std panic handler, I think. Let me open the bootstrap to make sure that I remember how to do it. It is in the std lib, I guess. It's in the panic. Yeah, we have panic handler, which is like the handle based on the string. Yeah, that's right. So panic handler is set up. Okay. Handle panics. Handle panics using this group. There you go. I want to do this here. I want to do this here. I want to do this here. Right? And we want to say handle panics is a group, which is the st group, and it should return the std panic handler t, right? Yeah, I guess, where we handle the panic t message string t. Okay, yes. And over here, I actually want, instead of a panic, to do the diagnostic. There we go. That's much better. Even although, like, technically, we probably don't want to catch the panics, and we want to instead, like, do this optionally here, right? That's okay. I'm just going to write the message, and the span is going to be the group span. Better than nothing. Okay. I will say like to do not catch panics, but instead use tuple get opt or something. I don't know. Because panics are more than just these errors. Right. Yeah, there we go. So now we have, instead of this panic message, we have this, which tells me where exactly it is, right? So over here, t kind is object, right? And why am I even trying here for this? Right, because I did this. Type is expect some type, because I copied it from the other place and I didn't remove that stuff. Okay, got it. You love the development hell of syntax decisions and semantics. Yeah, there was a lot of decisions in making a language. I think like going for the perfect immediately is like too difficult. I want something first, and then we'll iterate from there, right? Like, I already like my language. It's good. It's just compiling a little slowly, and the runtime is a little too slow, but we can improve on these things, and we could improve on the syntax, and some of the semantics are also in need of fixing, but it's okay. Okay, allocate type. Right, allocate type on stack. We are trying to. This is in JavaScript, so it doesn't really matter. I mean, let's do it on heap, actually, and on stack is done using the heap, because in JavaScript everything is heap technically. So yeah, there we go. Okay, expect expression got object, right? Object over here, right? We need this to be the proper expression. So we have a new expression called variant, right? In this case, so this is going to be the expression called variant, 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 right? And variant is root is the helpers expect a single child called the label. So if I have the label of the variant here, this is what we return. The type is going, so we must know the expected type here, right? We say that type is expected type expect known type in the it's the span, right? We expect this to be known, and I expect this to be a variant. You know what? This over here can be extracted into a function. It's okay. How do we do this? I want basically a function which like maybe we do it in two steps, right? We first expect type uh, enum, right? Which is having the type, which is the type, and I should return here the this set of names, basically, right? And then we will also expect variant, expect correct, check variant, right? So we check the variant to be in the specific thing. This also needs to like have the span for the error reporting, I guess, then. Right, we have type, we have span, we return the set of names, and then we check variant, which is the variant, which is a name of the variant, and we have the span, and we have the variant names, which is a set of strings, right? There we go. And this does not return anything, right? So this is this type, right? Enum variance is this. So enum variance is basically enum type expect type enum on the left hand side span, right? So this is this code. We do here with return. So we match that. We don't say enum type. We just say type here. We don't need a reference here. I feel like resolve type aliases. This takes the ownership of a type. It should not. Meh. Let's make this dereference that. To do should take type, should take a reference. So over here we do this, and span is just span. Okay. That would work. And then when we check variant, when we do this, then right, so we have the variant like this, and then we say variant, check variant of the enum variant in the right hand side span, right? So we say if variant names don't contain the variant, well, I mean, check variant should probably like what? It should actually take the type here. Yeah, it actually should take the type. So this is the variant of this type, right? And then the variant names here. Variant names. Oh, but then yeah, I need like the type span and the thing span then, right? Like it's like two spans because we want to report the error into different places. Maybe then we do something like this, you know? If we say like type is reference to type and span, right? And variant is string span, right? We can do this. So like a spend string, we can make like a spend type or whatever. Const with span t. It's just t and span. It's span like this, you know. So variant is with span string. And type is with span reference to type, right? So then we say that variant names is variant names is expect type enum type like this should work. And if not, variant names contains variant 0 then. So the span here is going to be variant span. Right, so we don't even need the variance then, right? We'll literally just say that we just want to, yeah, let's just check variant, right? Where variant is variant and span is a right-hand side span, right? And the type is the enum dot type, and this is like the left-hand side span. Right, there you go. So that's what we check. So it's going to automatically check that this enum type is an enum. So I don't need this. Right. There we go. And now in the actual variant, we just say that expected type must be known, and then so this is a label, and we say st helpers expect identifier, and then we also check variant. We also check variant, where variant is variant span is AST span, so this in this case the whole AST span, and the type is the type, and span I guess in this case also the whole AST span, because like we have the type inferred for the entire expression, and so we return the same thing. And then we have the expression, which is a variant. And do we have expression which is a variant? We do have expression which is a variant. Okay, nice. Development heaven. Hello, TLB miss. Development heaven is when you think about things, and development hell is when you actually need to implement them, right? Thinking about things is so nice. Need reference to type here. What else do you want? This is name. This is span. Sure. Okay, it's compiling. And then we will have like some unmatched branches, I guess. Because we don't have exhaustiveness checking. But no, first we cannot compile this because target. Wait, what is this? Copy val? Oh, copy impl. Oh, this is in the JavaScript runtime, right? This just returns any, so I should just like return the thing. Wait a second. This is a little bit. Yeah, because I said copy, which is just target is copy impl, and yeah, because this over here we have target as a reference to any, but this over here we just return any here. So we like do that, and then this returns any. So we see that like let mat target is. We don't do mat here, right? We just say target is any, and this is this. We say for members of T, we copy member of this, right? So we get member. What is get member? This returns the reference, right? Yes. Yeah, I just need to say that get member of target member. This is equal to copy impl of get member source. So there's like the member of value member dereferenced using the member type. There we go. So we're copying this. It's the type of the member. Yeah, sure. What about copy element? I can also over here say that target any is this. So we just say for lat of source. And over here, I just say that I want to push into the target, right? Target dot push copy element E. And so this should return like any like this source element. Wait, if this is array, shouldn't I like wait, hold on. If this is the array, then I need to know the type of the element here, right? It's almost like I want the actual like sum types here. Because these members only are over here, and in case of an array there's a single thing, which is the type of a value. Like I need to know the type of a value here is the thing. I don't think I want to support that. So let's instead do like the flat list here, right? So this is like the inner type, which is the type and or maybe like we say like you know like inner info type info, or I don't know, let's say details maybe, because details type info details, this is like dependent on the kind here, right? So which means that type info details is a union, right? Which either has the members or it has the array, or it has like the inner type, right? Which is a type info. Yeah, maybe we do this. So if this is an object, then we know that we have the so it's not like team members, it's t details members, right? And over here we know the element type because it's going to be the thing, you know. So we say that inner type is t details inner type, right? So when I copy the element, I need to copy impl the source element using the inner type. There you go. Without a semicolon. Okay. But this also means that I need in my compiler. So like I'm constructing the type info as like a helper in the compiler, and this needs to be like, yeah, so if this is the array, then I also need to like, yeah, we don't have the members directly, right? We instead say that we have the details, right? Let's say that we have the, let's say that we have details. So details is what? We just don't know what it is. Because, yeah, we're adding the... So add members is when we like set the details to be the members, right? But then... yeah, hold on a second. Yeah, we just say this, that. Let's say details is something here. So this is the yeah, and so yeah, so we say members. No, not members. Yeah, we say like the details. Right. Yes, like details is the object, right? With the fields. Yes. Details. Push back. So this is going to be the field where name is members. And we have a list of members. And so over here we have kind, and we have details, which is going to be the record with a single field. Well, with the record with details, right? Yeah. And the detail, and this is supposed to like have a single field, right? Yeah. Well, it means that the details should not be the array list like this. It actually, so like it should be right? Like by default in the other ones, in the primitive ones, right? We should still have something. Maybe I don't do it like this. What is this fields? Is this field even used? Oh, it's like supposed to be over here. Let mode fields is playlist, right? So this is when I create the final object. So when I have add members, I should say that hold on, maybe I call this details members, right? So this should give me the details object, basically expression to initialize the details, right? So this should return expression. I'm even capturing anything at this point then? I guess I'm not, right? Right, so we just say that details is array list new, and this is the list of like fields, and this is the only field that we have, which is the member, and we return shape is record details, type is named, and this was called like type info details, right? And we have the span, and that's what I return. So we over here we have details and kind. We have, let's do kind and details, right? So in this case, the kind is object, and the details is details members field, right? In this case, it's also object. And details members using the variants. And in these primitives, we say that it's primitive and details primitive. Right? And details primitive is like a function which returns so it's typing for details with a record. I need to push back. The name is primitive, and value is unit. Type is unit, and a little ugly, but that's okay. It means that, so yeah, because like we have like three things: a primitive, object, and array, right? So yeah, so in this case, it should be members, inner type, or well, I mean, this is like the array. This is like the manual sum type, basically, is what we're doing here. In case of a primitive, we just don't need any extra thing, so we have the unit type here, right? Because I still want to initialize something there. All right. But then in case of an array, in case of an array, I still want something, right? On say details, details with inner type, right? Where inner type is a reference to type, right? Or not even a reference. So we have the inner type, which is no. We need the type info here, which means that inner type is the identifier of that. Well, that's what the type info is. Type info is returning. It's a place expression, right? Yes. So the inner type, we say that shape is a reference to type info of the inner type. So over here we have a reference after all, right? So we have type info of the inner type, and this is the place, and we get the reference to that to construct the value. Right, so in this case we return array, and so this is list ref inner type, and over here we say details inner type. Okay. Unexpected let. Looks like I forgot the semicolon. Semicolon over here instead of a comma. Same here. I should definitely split this file into multiple files. It's already 2,000 lines here. Members is not in scope. Right, because we don't have members, we have like details. What is that? Array list. I'm expecting a list somewhere. Where's the thing over here? Record fields. It's probably like the details, right? Well, details is this already gives me the record. This gives me like the full expression, right? Yes. This already gives me the full expression, so I don't need to say the record details, right? We just say value is equal to details. Yep. Wait, this over here is something also weird. Where's the beginning of this error? Let's recompile from scratch. Yeah, it's compiling actually. So that was the incremental compilation bug then? Maybe? Type info is supposed to get alias resolved type. Okay. Type info is supposed to get alias resolved type. But what did we get? Yeah, because like we have the type, right? Let's instead do the diagnostic here. Instead of a panic, but this is the internal error, I guess. We just say that we got this type over here, right? Well, I'm supposed to, right? So when I'm calling the type info type, right? Details member. Yeah, because I'm like having a reference to something. Let's take a look. Right, type info. Yeah, we got member offset or name. Yeah, because member offset or name actually is the thing. That is correct. Yeah. So I think whenever I call the type info, or maybe like even in the beginning of the type info, how about this? How about we just say that type is resolve type aliases of the type. Yeah. We'll give it a reference after that. Sure, let's do that. Okay, now we have type info. It doesn't have field members. That's right. Over here, right? We don't say result members is a list. So this is when I'm creating the generic type, right? Yeah, result, type info, allocate on the heap. Initialize type info for struct. I have a feeling that type info for struct should be like, you know, result, and we have the list of the member fields. Passed as the argument here. Yeah. How about this? This is going to be a list of member field over here. So in the runtime, initialize type info for struct. This will have the members, right? Which is the list of member infos, right? So we say tKind is object, and we say that t details dot members is members, right? Yeah, and then we also potentially want to calculate well, in the other backend, so we might want to do something else. Let's do this. Type info doesn't have members. Yeah, okay, so we have a generic function. Yeah, because like now this is not necessarily there. So should this still be in the details? I mean, let's do the details. Dot members here, sure. Expect to type infos, but we got a reference to type info over here, right? But why did we expect? Oh, because copy. No, copy impl. Wait, copy impl actually takes as an argument the reference to type info. And member. Oh, member type is already a reference. But this error is saying right, because member type is already a reference. So this like is a double reference. The error is a little bit weird. Why is the error weird here? Like, am I not supposed to say the full type? Oh, it's because like I'm expecting because the error is pointing into this, right? This over here is expected to be a type info, but it is a reference, not the whole thing, right? We just need to like carefully look at this pen here, right? No, that's okay. So I just need to not do this. Source is not found in the current scope. What is source? This is just value. Right, and value should not even be dereferenced here. Okay, the pattern match is non-exhaustive over here. So this one we are all transparent to JavaScript now, right? I need to have the list expression transpiled to JavaScript. Okay. Well, there are multiple here, right, which are not present. It is the list expression. We will probably need the enum is, and we will need the variant. Maybe I had something else. Right. Let's say list elements. Right. So this should return the list. JavaScript AST has the. It does not have. Well, it should be called array. That's what they are called in JavaScript, right? We have an array of expressions, right? So we have the array elements in JavaScript, then we are going to do the opening square bracket, closing square bracket. We will not be doing dots here, I think. So we just say for element in elements into iter. We just literally print expression. Element. And it seems like I'm missing the new line after every field in the object. That's over here also. We want the new line. And we just print expression element. Right? And we have the array. Right. So we create a list. So we just need to convert every element. We need to like calculate every element and put that into the list elements. JS push back the variable, that's right. Because we put everything into the variable and yeah. Okay, I think that's it. If we have a variant, a variant name, I feel like the variant name, can I just have the string literal with name? Although, like, maybe later we will do the actual symbols. Let's start with actually just strings instead of symbols. It's okay. It seems like strings are also really fast in JavaScript, right? So let's just do that. Enum is, we have enum and variant, right? So in this case, I just need to basically compare. So like enum is basically a string then, right? And we just need to check that they're equal. So we need to say equal. Left hand side is var calculate enum, and right hand side is a string literal variant. Right. So in JavaScript AST, I need to have a new kind of expression, which is equal. Left hand side expression, right hand side expression. Right. So if we say equal, left hand side, right hand side, then we just print expression left hand side. We write triple equal and print expression right hand side. Okay. The expression is not a list, array list var. AST expression is not a list of vars. Wait, what? I have expression which is a var. Oh, it's called array, of course. In JavaScript they call it arrays. Right. Not lists. Okay, pattern match is not exhaustive over here because I also forgot about the index, right? So we have the indexing expression also as like a place expression. We have index. Let me see over here. Index, right? We have the list, place expression, and index, right? So we have a list, and index, right? Index is just an expression. A list is a place expression. So what we're going to do is we're going to calculate place of the list, and then get the list. This will return the expression itself, right? And we need to have the yeah, like I need to have the indexing operator in the JavaScript too, right? We index so JavaScript will you index not necessarily an array, right? So you index the object or whatever, right? And index is just var calculate index, right? Let's do it in 2 steps actually. Object is calculate plus list get, and index is calculate index, and then we return the object, and index is just var index, so like that. Which means that in JavaScript TST I need to have a new thing, which is the index object expression index expression. Index object index print expression object, write this square bracket, print expression index, write the closing bracket. Okay. Doesn't compile. Yeah, because it should be like. Oh, wait, index. Wait, what? JavaScript place is not index. Oh, yeah, this is supposed to be the place, right? Yes, this is supposed to be the place. Yeah, let's do like place of index object var index, right? Well, I mean, I don't like really need to, right? And just to, yeah, we need to have like an object with a getter and setter. So get is the thing that returns this expression, right? And set is a new value, which does the assignment. Right? Set is when we assign to the index of the object, we assign the new value. There we go. Yep, that's what we return. No way. Okay, we actually have the compilation of this thing to the JavaScript. Now, does this work? Is the other question. Color false. Okay, and into Node.js. It does not work because we have the unexpected token 4 over here. Yeah, that's right. Okay, that is because I understand this. This is because we have like the difference between the express. Yeah, this over here is like becoming the expression instead of a statement. So in order to convert this into the expression, even although this is a statement, we need to execute this in a lambda and stuff. Right? In the immediately invoked lambda. There are these 3 things that needs to be done like that. This, and that. There is also a possibility of changing the minicast to be an imperative language. I mean, not imperative, but like making it also have the distinction between the statements and the things. But we don't have that in the original cast anyway, so yeah. It doesn't matter. What we could do though is then like, since this is a statement, we can like statement like this, and we would like see if we are prefixed with statement, and we do something different, right? Because we can treat these native strings any way we want. Um, okay, let's do this statement like this. Why not? It just means in the JavaScript transpiler, when I have a native thing, right. Oh, we have the part. Oh, we have also the parts here. Yeah, that's right. Flat mode, first is true. First is false. How about this? I will say that if first and... Oh, wait, we don't have the starts with in this string, right? Starts with. How about I implement the starts with real quick? In this string, starts with is string, starts with prefix, which is this string. Let's have this named, and this is going to be a boolean. Well, I want to not only starts with, I want like I wanted like to be able to strip prefix, right? Strip prefix, and this will return an optional remainings of the string. And then if we do this, then we can also say that starts with prefix. This would return boolean, and this would just be done with the strip prefix is some, right? But if we do like just the strip prefix, we say that if prefix if string length as is less is more or equal than length of the prefix length, that prefix length is length of the prefix, right? So if this is that, and substring 0 prefix length is equal to the prefix right, then return some substring from prefix length of s, otherwise it's none. There we go. Let's try this. It doesn't work. Yeah, there we go. So we say string starts with right, starts with hello world, starts with prefix being hello, right? And this will return true. There we go. And then we say string starts with ABC, starts with prefix being B, and it's going to be false. Okay, nice. String starts with strip prefix. String strip prefix hello world. Prefix is hello, right? Yeah, some comma world. There we go. So yes, I say that if first if first, then if strip prefix, we want to strip prefix of the string, which is the statement colon space, right, is some statement is some, then return rest. But I will say that statement is true. Okay. Yeah. It's just that if statement, then we need to do something else, right? Oh, I need to like insert into the thing then first in order to make this an expression. Well, I mean, I'm calculating the expression, right? I can just insert this as a statement, so we can have a raw statement, so that we don't like actually do the lambda immediately invoked. We can literally invoke a statement here, which would be a little cleaner, I suppose. So if it's an expression, then we just do this as an expression. Otherwise, we return like the statement, which the value is going to be undefined. All right, but the thing, we need to insert statement, which is going to be a raw concat. It's But doesn't mean that the JavaScript AST, right? Like we have the raw, which is that, but we don't have this in the statements. Yeah, let's have like a raw statement too. Why not? But parts are still going to be the expressions, I suppose. Yeah, because if we have the interpolated part, then it must be like this. Yeah, so when I print the statement, yeah, we just do it like this. And then nothing compiles. Strip prefix is not there. Yeah, that's right. So I need to actually stop this and to update my cast. All right, minicast is taking longer actually than I expected, but that's okay. It's not that long. It has not been a week yet, right? Has it? The compile times are so bad. Are we at the point where it's compiling for a minute yet? It's close. It's getting close. I think it's like 50 seconds right now, right? 45. 46 seconds. What's my lines? We have 15,000 lines of code, including the standard library. Okay. All right. Wait, it runs? Is this right? It runs. I just think that this code doesn't actually do anything, does it? Right? Because we just create the generic type of int, and we have the generic function. Okay, and this generic function is like getting this field, like copying this stuff. Yeah, this is supposed to just be the code that creates this. So like, yeah, we don't see anything on the screen. How do I make something be seen on the screen with the generic functions like this? I mean, I just want to see. I just want to like debug print this, right? So we just say native console console log x, right? Let's do that. There we go. Oh wait, no, this is not right because field is something which has a getter and a setter. This is not correct because the field is supposed to be not the reference to an integer, but actually the integer, right? What if I say x dot field dot get here though? Oh, then we have the details, which is a primitive null, and this wait, what? I'm storing in the x the type info instead of storing the value. Okay, this is wrong. This is wrong. Okay, let's see what is happening here. Because the generic function, we're supposed to do what? We're supposed to do the get member of the result, which is this member, right? Okay. Can I over here say native console log result field? Although like this result field is supposed to give me the reference technically, so we're actually going to see the getter and setter, right? So it's like get this. Right, and it is undefined. Wait, what? It's undefined? Oh, yes, the result field is undefined, right. That's correct. Because this is the field of the result, and I'm trying to like initialize it here, right? Yes. Result is any. Because, yeah, we create the uninitialized thing. That makes sense. Right, I can like also print it over here in the beginning, right? In the beginning, we have the empty object, and then we're supposed to initialize it field by field. Right, there we go. So the question is, what's the field? Not the result field, but the actual field, right? And the field is supposed to be the 1 to 3. Okay, so like this is reference to undefined. This is reference to 1 to 3. The T is the type of the field there, right? Yeah. Yeah. By the way, this should not be copy because this, yeah, there's like a difference between the copies and the moves, I guess, because this is expensive. But let's make the copy first work though. To do move. But this means that the runtime copy, right? We have in the runtime JS, which is copy, which is not implemented correctly. We have the target and we have the source. T is type info. So we say copy impl. Oh wait, it's because I do the copy impl where source. I just have these arguments swapped. Yeah. Wait, what should be like the should the type be the last argument or the first argument? And the reason it's like type checked because this is any's, and we have like any versus any like in both places, kind of. um, What makes more sense, to have the type argument be the first or the last argument? I think the first actually makes more sense, no? But then it means that when I copy here, I copy type T from, and like, should the target or this thing be the first? We copy destination from the source. It's because like this was from memcopy, and memcopy takes the target first and then the source. Let's do that. Okay, well, this still doesn't work properly. But it is a reference to 1, 2, 3 now. But it should be 1, 2, 3 itself, right? So let's see here again. Oh, it's because copy impl is value is any, right? It's like in because this is no longer a reference to any. I actually need to dereference this. Here. Right. Yep. Yep. And now we have field 1, 2, 3. Okay. Well, I mean, the move is technically just literally. The move is literally just saying that the result field is equal to field, right? Yeah, we just cannot do this in this. Like, we basically just want to say that result field is equal to field like this, but this doesn't work in the C backend because this is of type any, and I don't know the size of it, so I don't know how to do this, right? Which is why this type argument is present here. So we just need to say move, I think, into the result field of that. There we go. And move is like a very yeah, move is still just memcopy. Move in C is same as copy in C, actually, right? But move in JavaScript and copy in JavaScript is different. Yeah. Yes. So move just says that target is equal to source. And that is like much easier than, much faster, supposedly. Okay, so generic example actually works. Okay. So the reason we were doing all of that, once again, is because I was trying to figure out what we transpile the generic functions and generic code into. And this is what we're supposed to transpile it into, right? So the generic functions are having the runtime type information, right? And then we do like some stuff here, which is a little bit weird. But it's okay. Maybe we also do this memoization so that the generic thing is working properly. I feel like I need to have like static variables though. I mean, I have constants which are actually treated as the variables, but I think I need to make a distinction between the mutable and the non-mutable ones. And I will need mutable global state for this. Right? But basically, when we have a generic type, we want to do the memoization here, so that we don't calculate it every time. And the way it would be done is like generic type memo or something, maybe is what we call it. And this could be like it's all about just the types, right? Or we leave this as a to-do. I don't know. Like I think it can be in the runtime, you know, generic. I don't know, memo. Memo. I don't know. Let's call it memo. Whatever. Memo is memoization. Type info memoization map. I don't know. Maybe. Like I feel like this should almost be a primitive of sorts. Another thing is that I want to actually support any expression here, and this means that because this is actually not calculated, like this actually should be the code that is running before main, I guess, which I don't do right now. Well, I mean, I do it in JavaScript, but not here, right? Kind of like initialize type info memoization, type info memoization, just like without the map part, right? So like every type has its own memoization thing, and this is basically just a map from type info to type info. No, actually it's not, because like some generic types have multiple type arguments. Now that I think about it, right? We should have multiple type arguments. So like the key to this map is actually not just a single type info. Right. So the key is different for every generic type, depending on the like the arguments here, right? Yeah. You know what? Let's forget about memoization. I will do it later. It's okay. We can calculate this every time. Although, like, if I just do it like that, where we allocate type on the heap, because we never deallocate this in the native code would lead to memory leaking. But as long as we use garbage collection, it probably should be fine. Even if I do it every time from scratch. Okay, so now the goal, I think, is to try to finish compiling from Kast to minicast. See if there is still anything that's missing. So right, Let's see here. Just minicast. Playground test. No STD, right? No. Wait, what? We have this tag. No, this is supposed to work, right? This was already supposed to work. We have something else. I just want to do the hello world, right? Like this. So this does compile the entire standard library. This is not going to work though, right? The reason this is not going to work is, so this is the issue that we had before. We have the generic types, which are different, but we should basically treat them. We should never have the generic types, right? Let me just remember what we are supposed to do here. If I have a generic function, right, it actually returns any, right? So this over here is a generic function. Wait, isn't this literally the code that I'm trying to do? How about we do this code, but yeah. Let's do this code in the playground here, right? And then we just minicast. There we go, like this. It says int32 is not found. Okay, int32 is native int32, right? Because we're doing this without the standard library, right? This is the very, very small example. There we go. So here we are transpiling to a code like this. We have 40 lines of minicast. All right, which is doing this. So this is the generic function. This is what we transpile it into, right? So we have the 0. So this over here is the type argument. The type. This is the type of a type, which is the type info, which right now is just empty like this. But it is part of the runtime, so we could convert the types into the type infos. Now then we say that t is this. Yeah, so like this is this argument. And then we return the new function. So this is the function that takes any as the argument and returns generic type t, right? But we don't know, like this is not correct. This is not correct. It has the field which is any, but that's not correct because we cannot like figure out the size of, like, we cannot have any's here basically. So like the entire thing must be any. Right? I think we do something like if we contain any, then the entire thing is any, right? But then also this should not like return any because this is not supposed to work. But instead we should say that if the function returns any, then it should instead be passed as the result argument with a reference to the result, because it's going to be allocated on the caller side. Actually, now that I'm thinking about it, why can we not do it in C? Like, what's the reason for C to not be able to return? Well, we need to like know the size of the thing somehow, right? So like, obviously the caller over here knows the size of the entire thing, right? And over here we can like figure out the size dynamically also. Um, I mean, yeah, pointers are easier, I suppose. Okay. I don't want to convert all of the functions though to have instead of like returning something to take the reference to the result because it's not always what we want, right? Only for this generic stuff. So we have what? I feel like here's my transpiler to minicast. First of all, we want the type of a type. So this over here right now is a struct, as an empty struct, right? Because this gives me the type definition, but this should just be the alias to named type info, right? That's what it is. And I mean, it's a type. It should technically be like a reference to the type info, right? So now this is not going to be found because in the just file, we need to, yeah, I need to like add the runtime, right? And the runtime is going to be source minicast back. It's just source mini backends JavaScript runtime MKS, right? Right. Now it says that this type cannot be used as a record. It seems like I need a space here in this error message too. But this cannot be used as a record over here, right? Because this is a type info, right? So when we have in the transpiler, we have the value type. This should not be an empty object, but this is an actual type, right? So I need to actually transpile type, right? But then I need to also say this is supposed to be an expression. So we need to have the type info expression. Type info of this. Transpile type just gives me the type here, yeah. So mini AST expression should have the type info of type, right? Type info does need surround And over here, type info type. This is just going to write at type info. Print type, right? There we go. Okay. So now we expected a reference got type info struct, right? Right? Because this is supposed to be a reference to the type info, not the type info itself. It's a reference to... Oh, wait. So should type info be the place expression? Maybe type info is a place expression, actually. Okay. So now over here, right, we say that we expected generic type int, but we got a generic type t. There we go. Right? Yeah. So, yes. Because this is a function, this function returns generic type t, right? But we expect a generic type int. And these are different types, which means that this should return any instead, because it contains the generic argument. Right. So we can just do this first. But then this will not work because we cannot just say tuple.field is equal to that, because we don't know what fields there, if this is changed with any, right? Which is what we want. Then we cannot assign a field to the type of any, right? Because we don't know the structure of this. I mean, we can do this in JavaScript, but we cannot do this in a lower level language. We cannot set a field of a void star. So we need to get the type information here. Right? So that's so one part is to convert this to any. Another part is when the function returns any, it should take the any as an argument instead. Also, all of the any's should be behind a reference always. Mm-hmm. Mm-hmm. Is this going to be like a post-processing though? Can I make this to be post-processing? No, I cannot. Really. Because we still need to... I mean, is there a way to do it like this? Maybe I can have a feature in minicast still, instead of doing it here, right? Can we return any? That's the question, right? So let's open up the this example in C, right? So what we want is we want to have a function which is generic, which is not monomorphized, so it returns something which we don't know statically, which is why instead of returning the result, we are taking a reference to the result, which is going to be allocated by the caller instead on the stack, right? So can I convert to this from the minicast though? I don't know, because like I still need to know the type of the result. I mean, we still need to allocate this in the caller, and is the important part. Even although I can pass the the types, the type infos, I can pass the type infos easily. It's just like this translation, which is not the easiest one. I mean, unless I have all of the functions done like that. Do I want all the functions to be done like that? I don't know. Probably not. Let's see. I want this over here is going to be code in the... Let's go here. Go temp minicast, right? So I want to have a function, right? Like function f, which just returns any. But this returns any like of t, which is type info, right? That's what we want. Somehow. To be done. So say void f, right? So we have type def struct type info, type info, right? So this is going to basically say size, which is like int or whatever. So because in C, so like one of the obvious things is what we can do is we can return void star, of course, right? And then we would like, if we have t, if we have type info t here, right? Then we could basically malloc malloc t size, right? But we don't want to malloc is the thing. we want to allocate on the stack, which is why we, instead of doing this, are doing this, right? And then over here we do some code. And then in main, and in main, if I want to call the function, I just have like int here, right? Like this. So I have int reference to x, right? Then I say over here int x. F. Well, I mean, we're not doing like any initialization of this anyway, so it doesn't really matter. Here. Like, we basically kind of want to still write just this code. Right? And so like this over here, okay, hold on. Maybe we can do this. Because this thing returns any, right? This thing returns any, but we know that the type of this is actually int. Right? Yeah. Hold on. I think I can do this in the minicast. So basically, this means that whenever I call the function that returns any, and we know the result type, we can automatically like first allocate this on the stack, and then pass it as the last argument to the function when transpiling to C. Yes, we can do that. If we know this type statically, right? But now what if this happens in the generic code though? Because in the generic code, right, if we have like function f and this function f wants to like call function g of t, right? Yes. So we say const g is like literally the same stuff, right? I can return like uninitialized here or whatever. It doesn't really matter. But what matters is that I return the function g. And like I want to do something. I want to store it in a variable, right? That temp is this. Then we do something, and then we also return this temporary, right? Which means that this, since this is any, this would be transpiled in JavaScript, in C, the function g. Okay, so this we say like over here, right? Let temp be gt, right? And we have the okay, yes, and we cannot do this. So instead of doing that, we are saying that we're saying gt reference to temp, right? And then we return temp, which means that we need to like mem copy basically here, right? From like into result from temp using the the t size, right? That's how we make this be put into the result. We don't say temp, we say that temp is void star actually, which means that we do this. And over here we allocate these using the t size, right? So in case of a statically known type, we can allocate it on the stack easily by just declaring a variable and not initializing it. But in the case of the generic stuff, we need to allocate on the stack using this. But I want to still keep this code in minicast, maybe to be like that, where this would still be of type any, right? But in this case, we know how much size to allocate it on the stack, and in this case, we don't. Which means that any does not actually work. Which means that any does not actually work. Doesn't it mean, maybe in minicast, I can say that this is... Maybe we can have like a simple thing where we can have any of type T, you know? So this is a void star, but which corresponds to this type info. So we can have this as a built-in, maybe. You know? So we need to have like... So when we describe the type, it might be the type which depends on the runtime, right? Which is what we do here. And this would be, and this must be the type of this argument must be the type, the variable of type info, right? Which we then would be able to convert automatically to the allocate. And this means that I could make this conversion in the minicast instead of it being in cast, right? To minicast. So this just complicates the minicast a little bit, but I think it might be worth it. Because like, and then when we compile this to JavaScript, we don't need this, and this just becomes any type, right? Yeah. Does it mean that I also should be able to like annotate this here? What would this even mean? What would this even mean? I feel like this should not be usable in the return position though. Because like when I detect the result type of this, I don't want to figure out that this comes from this argument here, right? I don't. And also like we can sometimes construct the type info like inside and stuff. Yeah, we don't want that. So we don't support this in return position at all. Right? Is it worth doing this in minicast? What about the arguments, right? What about the arguments? Like if I have the function that takes the argument of type t, I would also need to do like the argument like this, right? Which is going to be like reference to arg, right? And we still have like int arg. If this is also supposed to be of type t, right? I feel like in the arguments, it is probably okay to support this, right? Because like basically we have the any of type T, which is the argument, right? And why is this important to support this? Because this gives me the information about the type, so we need to, which gives me the information of like how to copy and move this to other locations if we need to, right? Yeah. Um, but at the same time, if I have the code in Kast, right, which is like the generic, right? Like for example, option is sum, right? This has the type which is like T option T into Boolean, right? How do we convert that? We need to say like is sum is T type info. But then the option here, this option has the type which is going to be constructed at runtime. So we don't have that. I feel like maybe for that reason we don't do this here. Well, I mean, we need to like construct all of the types inside for all of the any types, I guess, maybe. You know, like we would still call say that this is any, this returns boolean, and we would say that like option T is basically option T, right? Where because like option is the type function, right? Option is T type info, returning the type info, right? Somehow. So over here we calculate this, and now we can say that option is any of the option T, right? I guess I could like create this code. Maybe any option T is equal to opt, right? So we like elaborate the type here a little further. So in C, this is represented as a pointer, but in JavaScript, then we don't need to like have this as a pointer, right? Actually, I'm actually also wondering about the Go language. Then Go language. How would I do this in the Go? I need to assign the value to the reference, which is dynamically typed, right? Because Golang but Golang interfaces, if I use like the empty interface or whatever, they are passed by reference, right? So I cannot just say that it's this, right? So like if I it's not going to be the empty interface, then it's going to be the interface that knows how to copy itself still, right? Under the hood interface values can be thought of as a tuple of a value and a concrete type. Oh wait, or is it not? The value, how it holds a value of specific. Is it a value or is it a pointer to the value? Are Golang interfaces passed by value or by reference? And Go interfaces are strictly passed by value. However, they often behave, but they're passed by reference because they are internal descriptors. Creating pointer to the underlying data. Yes, they have a pointer to the underlying data, right? So like, so I need to have the yeah. If I have like var I shape, if you assign a pointer, the interface stores a copy of that pointer. Right, but what if I don't store the pointer? What if I store like this square as the interface? Actually, we should just try this, right? Let's go to yeah, let's go to Go. So I have a value foo, which is struct, right? Can I say that foo is foo where value is 1, 2, 3? Is this correct Go syntax? Is it colon there? Right. And then we have like interface with like type, any interface, like this, right? So I want to like any let foo any it's not let, right? It's var is equal to foo, right? And I want to fmt print ln foo. Wait, can you just print the foo here like this? Can you print foo any? Can you print anything in Golang? Yeah, you can print anything, it seems, right? Okay. So the question is, if I say so if I say what do I want to say? Right? I want to say that like foo copied is foo. Let's try this. And then I say foo copied dot value is 456, right? So let's print foo and then let's print foo copied, right? That's what I want. Right? And print foo any for whatever. So that Golang doesn't complain. Right? So yes, as you can see, I have when I copied the foo into foo copied, right? The original value stays the same even if I modify the foo. Now, what is if this happens if I like? Well, I mean, if I say foo copied is foo any, this is not going to work, right? Can I say like var foo copied of type foo is this? Can I say like dot foo? Right, that's going to work. That's going to be the same. No, that makes sense. What I want is to like have a reference, like, right? Can I have a reference to foo, which is like a reference to foo any. So this is a reference to the interface, and I want to cast this. Invalid operation. Foo any value of type star any is not an interface. Wait, you cannot like cast the things which are pointers to interfaces into pointers to values in Go? You can only do this on the interfaces? Okay, how about... Yeah, wait, so which basically means that I cannot mutate the value behind the interface? Right? Otherwise, I just copy it when I cast it. Right? Wait, so I cannot have the immutable reference, the interface. Golang reference to any. Go is strictly passed by a value, meaning every argument is copied when it passed by a function. However, you can achieve the reference behavior by passing a pointer. Generates a pointer to a variable star used to declare a pointer type or a reference. Modifying the data passing a pointer allows a pointer instead of a local copy. Well, I mean, so like I can modify the reference to any, right? In Golang by saying like I can say that like a reference to who any. Let's ref to any is this, right? And then I can say that like star foo any. Is that how you do reference? Is equal to hello world. Wait, what is this? Cannot indirect foo any? Oh wait, no. Yeah. We can like we want to say ref to any is equal to hello world, right? Yeah, there we go. Does mean that foo any is now hello world. It is exactly what it means, right? So like this means though that if I want to mutate the object, then I would need to copy it into a new object first. Is that right? Because I cannot exactly cast the reference to any to a reference to a concrete type, right? So if I want to mutate this, right, like I cannot say plus equal 1 here, right? I cannot. Right? What I can do though is I can say like star ref to any and then cast this to foo and then say dot value and then say +1 and then say that this is foo where the value is this, right? Is that right? That's how you mutate, by copying and then like doing that. And this is now foo, any is 1 to 4, right? But okay. Well, it means that if I want to have a reference to any, then it's still going to be so we don't take reference to any's, right? We have references to the original objects, and then cast them to any. Okay. Oh my god. Right. Right. So we can say that like var ref to foo, reference to foo, which is like the any reference to foo, right? Any is reference to foo, then, right? Which is this. Then we say ref to foo dot star foo dot value plus equal 1, right? Ref to foo. And this modifies the foo directly. Yep. But then it means that if I want to have a reference, if I want to have any to be converted into a reference to any, how would I do that without knowing the type? Can I do that? Is that possible? Golang. Because like I don't know what is stored there, but I still want to have a reference to the value which is owned instead of like being passed by reference, right? You know. Why do they not allow that? Can I convert in Golang reference to any to star and no. Is a pointer to a box. Instead the box could be an int, right? Like can I do the assertion? We can type, we can dereference, type assert the underlying type, optionally takes its address again. So how would I mutate a big struct stored in any? you usually store a copy. When you pull it out, you're poking a clone. Right. This gives me a copy. Store a pointer. So I never want to store the actual value. I always want the when I do the any to be the pointer, right? The reference to the data. But then how do I copy the data behind the point? Okay. But if I always store pointers behind pointers in any, I still want sometimes to copy values into a different variable of type any, even without knowing concurrent type. Can I do that? Still doable. We have this, extract the value, copy it, copy back to another any. The only general solution, reflect. Because Go does not do unknown type cloning natively. Okay, so like you actually, yeah, I guess like, and this is the reason why we don't do the any type, basically, right? When I translate to Go. So yes, this is why we have type any, which is the interface which knows how to clone itself, right? Clone. Clone. Can you like refer to self here? Can you not interface to like make the return type to be the type of self? And by the way, when you have a method, this is the interface. What is the method receiver here? Is it receiving the copy of the object or the reference? Or like, can you like, when you say like i.am, right? What does this even mean? Is it going to mutate I, or is it going to not mutate I? I don't want the tour. I want the specification or something. Interface types. So I mean, this interface is implemented for the, like, you just implement it for the pointer, basically, not for the type itself, right? That's what I'm guessing. Okay. So clone is implemented for what? Really? For the pointer to every type that we want to clone, right? Right. But how do you do this for native types? Oh my god, this is so wrong. Oh my god. You can, because like this is not the traits. This is the stupid duck typed interface of Go. How do I clone an integer? I cannot implement this. Like, is there no overhead if I say like type int which is a struct which contains the actual value of type int inside. Is this like zero cost in Go? Because then I can have the function which takes the reference to int and then it's cloning it, right? And also I still didn't know how to specify the result type, which is going to be like self. Golang clone interface. It just returns the cloner, right? Which is also dynamically typed, technically, right? Like that's how you do self, but it's not like exactly self. So this like returns any, right? Now you do like self star int clone, and this returns int, right? And I just return a reference to star self. Reference to star x will be simplified to x. It will not copy x, and this is not even copying it. Okay, how can I copy it, right? We say that copy is this, and then we return the reference to copy, right? And this is not going to be like a simple copy. This will like have the overhead in Golang because this is garbage, because this like now escaping the local variable, escaping the function, and it probably will not be that easy to figure things out. Because there's no lifetimes here, of course. But can I say that x is int values 1 to 3, and then I say like x any of type any is, so I need a reference to x then, var equal we have wrong type formatted clone, right? Because this should not return the star int, this should return any instead. It's going to be a reference to the copy, of course. And because of that, we have like, yeah, like there's a problem with that, because this is going to add a lot of overhead that would not be needed otherwise. Well, no. No. We don't do the pointers. We do the any interface which knows how to clone, right? But it does not take the pointers. No, it does not take the pointers. No, but then I cannot mutate the reference directly, because then I would need to like copy the object instead. Oh my god, why does it go so bad? Okay. Another way. Boom, boom. I don't really understand why they don't allow you to cast the reference to the interface, to a reference to the concrete type. Why? Close this. Doesn't Golang allow references to interfaces to be type to be casted with assertion to references to concrete types. Pointer to interface is not the same as pointer to the underlying data. Right. That's correct. Or maybe, okay. The correct pattern. You need to assert. Okay. Okay, but can I get a reference to the values stored in the interface without knowing the type? No. Unless we already store the thing there, right? But if I have like an owned thing, right? I like what I can do is I can copy the value out, construct the reference to the value, and now we have a reference as the any inside of the any, right? Okay. But I cannot do that. Use a reflection. Reflect. Value of I. Be kind. Pointer. Oh wait, but is reflection implemented like so that it's doesn't have the cost, right? Like I imagine, I guess maybe like it's not the clone that's needed. Maybe what's needed is like get reference, you know, and to get the reference to the thing that is stored inside of the thing. No, and then I would like, yeah, this is so weird. One second. Okay, I'm now not sure. What do we do about this? Well, I mean, we can accept a little bit of the right. Like we were supposed to be able to have a reference to the object of dynamical to the field of an object of dynamically typed thing. I thought I would be able to do this in Go, but it seems like I'm not. So Golang reflect. Let's see at this package. Package reflect implements runtime reflection. Allowing a program to manipulate objects with arbitrary types. The typical use is to take a value with static type interface and extract its dynamic type information by calling type of, which returns a type. A call to value of returns a value representing the runtime data. 0 takes a type and returns a value representing the 0 value for that type. See the laws of reflection. So like, is this the built-in things though, right? Which don't have the overhead. Right? Like they have the function which called copy, copies the contents of source into the destination until either destination has been filled or destination or the source has been exhausted. What does this even mean? It returns the number of elements copied. Oh, they must each have kind of like slice or array. Yeah, that's right. Okay. Fine. Field by name. Struct type. I mean type. Check a value with static type interface. We want type of. Why is type of part of the type if it's not receiving the type as the receiver? Okay. Type of returns the reflection type that represents the dynamic type. Right. And then you have the value of, which is like in the middle of the value probably, right? LMTUV. Wait, no, there is no value of. Where's the value of? Control F, value of. Oh, right. Because it's sorted where there is the static and then the methods separately. Value of returns the value. Okay, wait. So this is what we do, right? We have a value. So the question is, does this have the overhead? All right. I would expect that like maybe like querying the type information would actually be a problem, but a value, this is the any interface without. This is still like the any interface basically, right? we can just like query it or whatever. So we can have a value and we can have the address. Address returns a pointer value representing the address of V. It panics if value can address return false. Can address reports where the value can be obtained with the address. Such values are called addressable. A value is addressable if it's an element of a slice, an element of the addressable array. Yes, that's right. Okay. That's right. So this does not have the overhead, right? Because this is still like this is the built-in thing. I'm assuming. But is it actually? Does reflect have overhead in Golang? Has significant performance overhead compared to direct statically typed operation. The type checks. Creating type reflect value, which can increase the memory usage. But why would like creating the value increase the memory usage? Isn't this the same as like the raw value already? What's the representation of the reflect value? How is reflect dot value defined in Golang? Internal definition. Internally, it's defined over there with two primary components. The ABI type, pointer to the metadata, describing the value's dynamic type, and the unsafe pointer, pointer to the actual data stored in memory, and flag, an internal bit mask that tracks the metadata. Like, but isn't this the same as the interface representation, or is it not? Or is this not the same? Bit mask, addressable, settable, or exported. Is converting is reflect value of does reflect value of have overhead in Golang. Reflection moves validation. Yes, but the value of does not need to do any type checking, right? But value of often causes the values to escape to the heap. Are they not already on the heap if we are storing them in the interface? What about if we look into existentialization? How would I implement existentialization of generics if I was transpiling to Golang? Oh, you can have like unsafe pointers, right? Hold on, you can have unsafe pointers in Golang. That's right. So we don't do the any's, right? Hold on, Golang unsafe pointer. Package unsafe contains information that step around the type safety of Go programs. It may be not portable and are not protected by the Go 1 compatibility guidelines. You have a line of arbitrary type. Offset of size of string. String data, arbitrary type. Slice. Slice data, integer type. Pointer. So arbitrary type. Arbitrary type is here for the purposes of documentation only and is not actually part of the unsafe package. It represents the type of the arbitrary Go expression. Right. Now, I guess we can do something with unsafe then, but uh, yeah, we were thinking of changing this generic example into the code that actually returns any type, right? And I mean, this, yeah, so like this over here is actually passed by value. This over here is the result. So this just returns any, right? Type info, and this would be just like a function takes any, returns any. So generic type of t. Yeah, we can do this. X is generic type of t is equal to generic function. You know what? Let's make this flattened like this. Doesn't really matter much. Hello, Keith Fletcher. Yeah, like I was thinking of like instead of trying to mimic the C semantics, where we cannot return like dynamically sized types, we would do this when transpiling from the minicast to the C, and then we don't need to do that if we transpile to other languages which support these things. So I actually take any, return any, right? But so like since this function returns any, which we don't know the type of, we need to know, and we want this to be allocated on the stack. The size of the stack allocation will be determined by this type annotation here. Right? So we know the size, but if we have a function, a generic function that calls another generic function underneath, right? Yeah, and how do I write this code even then? Right? We like because we were getting the result field of this. Right, I want the expression of any type. Because we don't have the result anymore here. Right? Don't I just say that? So we have the generic type of T is the generic type T, like this. We have the type information about this. And then I say that result is equal. So the result is the type. So I want like any of generic type of T, right? Because we don't know the concrete type here. Right? Like, can I still make this look like the normal code? Right over here, I just return the object with the field. So I can just return an object where field is equal to field, right? That's what we want. But we don't know what's the index of this field now, so we don't want, and we don't want to look it up based on the name, of course. Which is why we were doing this thing instead. Yeah, who even knows like about the order of the fields in a type? Should Kast know about this? Hello, Nigel. Seems like I need to think about more things. Well, I mean, like the way we do it right now, it like is working. It would work with C, but like, yeah. So Nigel, I just made this like things work, where we would transpile the generic code into the existentialized code, where we have the any. So this is basically the void star, right? Just like I was doing in the C. But then I was thinking that like this, like conversion from the regular cast code to this would be difficult. So yeah, I don't know. I was just trying to think if I could make this conversion in minicast instead, where minicast would still be able to return the. Let's at least like flatten this though, right? So like let's do that. So generic function has the type information, the field, and the result. So instead of returning result, it takes the pointer to the result, and then it initializes and it uses like the moving, move this over here. Right? And this works right now. So this would be like the void star, but this is like too close to C is the problem. Flatten generic minicast example. Right? Like and also this has overhead when I'm transpiling to JavaScript. And also I realized that in Golang you cannot have a reference to the any and treat it as a reference to a concrete type, because because it doesn't work like that in Golang. Well, yeah, it does. I guess like yeah, it's no, it does. I guess, right? Does it? Yeah, like I need to be able to copy the thing from one place to the other place, though. Right. Yeah. But in order to copy, we could use the reflect stuff. No, in star void star. Well, you have the empty interfaces in Golang, but there is a problem where like you cannot like you cannot have a reference to a reference. No, you can. Hold on. I don't know. I thought something was not possible, but I already forgot what I was just looking up. Hello, brainoid. Let's just talk about C versus JavaScript, right? So in JavaScript, the references are like having the overhead. So instead, because we can't just return anything, I would still want to write the code like this, which instead of having the return value passed like that, we would want to return any here, right? And we take this, technically this is by ownership, but we take from like C the value behind the pointer, but we still like own it semantically, which is why we use the move here, right? So what we want is this technically, right? And can this conversion happen automatically in minicast, right? And in order for this to work, in order to return the any type, right, in C, because like we don't know the size of it, it means that this should be still allocated by the caller, because the caller knows the type, probably, right? Or we should be able to know the size of it. I mean, yeah. I mean, the caller should, to understand what we return, needs to know the size of it somehow, right? So if it's statically known, we could do the translation automatically like this, well, because like we know the resulting type, we know that this returns any, so we could generate the stack allocation and then passing it as the last argument automatically, right? So then I don't need to do that in cast to minicast translation. But if I do the but then the problem is when we call is like okay, let's ignore this actually, right? How do we do this implementation now of the returning the any type, right? Because we need to be able to have the local variables of any type too, right? So we want to just say result any, right? So in the original code, we just return the field is equal to field, right? Like this, and then we return result, right? This is a little bit more verbose. So, but we cannot initialize the field of any, right? That's not possible. We can construct the type information dynamically, but then we know the field number 0. And this is what minicast could do. This is like field number 0. Maybe we do like this syntax, field number 0 in this type for any, and that would like convert this thing automatically. And then in order to like know what is the run type information where we would get the field number 0 from, that would be like it is any, but with this run type information, you know. So I was thinking of doing something like this in minicast, where you have the type, I don't know, maybe it's not like any, but it's like dynamically typed, right? Dynamic type, where the type is stored in this variable, basically. Right? But then I cannot refer to the fields by the name. Well, I mean, we can, but that would be too much overhead. We want to refer to the fields by index in this case. Right? So this means that in order to create this, we would need to allocate it on the stack by the known size, which is stored inside of the type information here, known at runtime. We would be able to do that, and then we would like initialize all the fields by getting a reference to the field, which we can do by like doing this. So instead of doing this explicitly like I was doing before, we would be able to do this translation in minicast, you know. And so, yeah, so like over here, we're still constructing this value on the stack, but then I want to return it. But returning it, since we're returning any, would like when we transpile to C, this would be the, this would instead be the hidden argument instead of the returning, right? This would be the argument, which is a void star, right? And then we just want to basically to move from this local variable to the return, which is just a mem copy, which we would be able to do because we know the dynamic size of it, you know. Is this too complicated for minicast? Should we have it in minicast or should we not? Like, this is not really like a generic type. So we don't need to do the generic still. It's a different thing. Is there like any language that does something similar to that? Probably not. Does this make sense even? And and the good thing about this is that when I convert and when I transpile to not C but to a higher level language, which like JavaScript, then this is just going to be like basically as is, right? The only thing is that I still would need to look up the field name here. But at the same time, hold on, maybe like because we're expecting this to be the field, like we kind of know the field name here, you know, is the good thing. So we know that it's the field named field, and the index of the field is 0, right? So in case of the JavaScript, we would use the name of the field, and in case of the C, we would use the index. And like in case of the JavaScript, then we don't even need to look into the type information, right? Which is how like the current cast is transpiled to the minicast, to JavaScript, right? Because we don't do the types. Should it be like dot field 0 instead? Well, it is just the syntax, which like doesn't matter much, I suppose. Well, I mean, we can always like treat these fields as like they must be written in order in this case, and then I would not need to do that, and then we would just be able to still say field is field. But I don't know. Maybe like the explicitness is actually nice here, because then I would be able to initialize them out of order too. Right? Does this give me all the information that's needed? And then we can do the translation ourselves. And then do I need this to be actually calculated, right? Because like this type, I don't even need to calculate it in JavaScript technically, so we can make the JavaScript faster also. Yeah, because we like just do this. So can I make this? So basically this is a type generic type T, right? So we have a type which is like the type of this depends on the runtime. This reminds you of reflection in Java. I mean, it kind of is, yes. It is a reflection. But the but we're supposed to like produce efficient code when eventually with it also. Well, relatively efficient, I guess. It is still like all of this is because of the trade-off of the me not wanting to do monomorphization. We could just also give up and go into monomorphization route. Maybe monomorphization is actually easier to implement than like thinking about all of this. And then once we have that working, we can think about existentialization later. Monomorphization should be relatively easy. I just need to evaluate things at compile time in my main cast, and that's it. Yeah, I think it should not be that. I mean, yeah. Yeah, we don't like sometimes we do have though in the current code the generics which cannot be like we have the generic closures sometimes which we would not be able to do like that. The only reason I'm doing this is for the functions that technically supposed to return to never return because I don't have the never type, right? Like for example, this diagnostic, right? Right. So this is how we specify the type that never returns. Just return any type. So this is generic, which means that when I want to construct like over here, right? I'm creating this lambda, which is a generic. So how would I monomorphize that? But at the same time, this does not need to be monomorphized because I'm actually not using the type T inside of the body of this function. And I can literally just say that this returns any and like get rid of the generic even attribute. Kind of, right? Actually, we can we like probably supporting the never type in minicast is easier than in cast actually. It does not feel that mini in minicast. Well, it's not the microcast, you know, it's the minicast. um, so basically, this would allow us to specify the type, which is supposed to be calculated at runtime in the form of the type info. So this is expression which values to the type info here. You know? Yeah. So I mean, technically, this over here is also like the dynamic type of the type generic of the type T, technically, right? Yeah, like this actually allows me to like do this, right? So this returns generic type T, And this is return, and this is the of type T here, right? So in this case, we actually see more type information in the minicast source. So the DNT would be the void star in C. Well, I don't even need the type information then. We pass that runtime in the language like the JavaScript, technically, right? Well, I mean, I do pass it anyway. Oh. Like, this is definitely something that I don't want to support, right? Or do I? I mean, if I say that this is like explicitly dynamic, this is the type, this is the expression that evaluates, but I would only evaluate this expression basically inside of the body of the function, right? If I need to. Right? And now since I know that this is what it returns, we can just say that it is this. Right? Which is going to look basically like the original function. We just right? We just say that if something contains the generic type, then it must be the like dynamic. Right? It's dynamically typed thing. Which I mean, at this point, we almost like can detect that it's dynamic automatically and just do this. And just do this. Well, I mean, it's yeah. And the problem is like I cannot like test this much until we do have another backend than JavaScript, right? I feel like I need to work on all the things at the same time. Maybe not C, right? But Go lang would be good enough, maybe. Or do I want to do C? How difficult would it be to convert all of this to C? If I don't have the closures, I guess. This would be not too difficult. Maybe. I mean, we can try converting this to C. What's better? foo is A in T, B in T, into in T, or foo is A, B is to this. Well, we need to give it the types, right? Because otherwise, how do I convert it? Like the DNT makes it explicit what we want this to be like compiled down into, right? Like in regular Kast, we just say like it's not a dynamically typed language, right? Supposedly, just like C is not dynamically typed, but in C we still want some things to be like typed dynamically. If we don't do monomorphization, I think explicit like opt into dynamicness is better here. And like it's not the dynamic, it is the any type, yes, but it's not like exactly the any type though. And the reason why it's not the any type is because we don't store the type information inside the value. We don't have the universal value representation like the JVM does. We don't want that. And we don't want the any C++ has any type. C++ any type. But is it a different thing though? No, C++ any type is basically, you mean like std any type? Well, I mean this is same as the Rust's din any then probably, right? Right. So like it is different though, right? There is a big problem with the din any. I'm actually wondering how does they do it in C++, right? Like in Rust, you cannot have the din any unless you have an indirection, right? You need to store it in behind a box, which adds overhead, or you need to like have a pointer to it. And I'm not even sure if you can like construct the din any on the stack in Rust. But like the alternative of that in C would be the void star, which can be actually allocated on the stack. So if this is implemented in the std, this probably is like storing it in the heap, right? Storing in the heap is like we could go that route, yes. Like I'm trying to be like not like too inefficient though. You know? So you just have the type ID plus the pointer to the value there, I'm assuming, right? No, this is type info. Type. std any. std any. The class that describes type-safe container for single values of any copy constructible type. Any object or class that stores typically implements non-throw move constructible. Where's the implementation? Where's the thing? Like it cannot be the unsized object though, right? Because C++ does not support dynamically sized types, I'm pretty sure. Anyway. Being stored on the stack, does it? Implementation of std any. std any is a modern void star. Storage with small buffer optimization. std any uses internal buffer to store objects directly, or otherwise it does use the dynamic allocation, right? And then like how small is small, right? So the internal buffer is 16 bytes in GCC and up to 64 bytes in MSVC, right? Yeah. So it's basically dynamically typed. And otherwise, like you basically like use a lot more memory, even for things that like technically take it says up to 46 bytes in MSVC. So like basically if you store an integer in an any, it will take, instead of 4 bytes, 64 bytes, right? So you automatically use 16 times more memory than needed in these cases. Yeah, that's what we're trying to avoid, kind of. But this is not that easy. Yes, this is difficult. And like the other difficult part is like, where do I put this complexity? Do I put it in minicast or do I put it in cast, right? In cast to minicast translation. I'm kind of thinking that this specific thing could go into the minicast. Right? This is the implementation. vtable for types that must be heap allocated and any. There we go. So there are specific types that must be heap allocated. Then you store the destroy function, the copy function. Yeah. Yeah. So like the problem with this is that like what we want, like let's say that we have a generic function, right? We have a function foo, which operates over the lists of the generic types, right? We have like t, and then we have the list of t's, whatever, like vector, or like I don't know if we want to be more C++ e, right? So like we don't want this to be any, right? We don't want to convert the entire vector, every element in it, into the any. We don't want to box every value. We want to still like yeah, right. Like, can you even do that with any's? Because you would only be able to cast it into a vector of specific types, right? So you cannot do anything until you know the concrete type, actually, probably, even in C++, right? Which makes sense. You would not be able to do that in Rust either. But like, what we want instead is we want to know like the generic the generic like layout of a vector, which in C++ makes it even more impossible because the layout of a vector depends on the actual type argument there. Well, I mean, no, it kind of is possible, like to calculate it at runtime, anyway. But yeah, it's not that obvious anymore, I guess, because like they do the bit sets for the vector of booleans, for example. But yeah, the idea is we want to use the same representation as if this was a concrete type, and then we just like access this in a dynamic manner. But the these things, they change the runtime, they change the memory layout too. which is instead of having the type information stored inside of the value, we store the type information outside of the value. We do the decoupling of the data versus the type, right? And then if you have a list of elements, then you don't need to store the type in every element. You just need to know the type of every element in the list, because we know that all of them are having the same type, right? Which would be more efficient and faster. Right. I kind of like this. I kind of like this. I kind of like this. And I think, though, that in order to test this properly, maybe I should try to implement the C backend after all. Like even for like a subset, maybe not the full C backend. Should I try like C or Go first? Actually, I don't know. I feel like because like the target destination is C, I want to like at least like try for this concept to do the C directly first and not even go through the Golang, which is like the middle ground. What am I doing for the asyncness? Yeah, and then we can for now ignore asyncness actually. When we like the code, like here's the thing about the async. I'm actually not using the asyncness in Kast in any of the programs that I've written so far. I am not using it. The only reason we need to do async is because the functions that are normally sync are async in JavaScript, right? For example, when you make a game and you want to like wait until the next frame, you do request animation frame in the browser, which calls a callback, right? So you cannot just block and wait for the next frame. This thing has to be async. Or like, I don't know, reading from a file. There are sync APIs in JavaScript, but in general it's async, right? Like reading a line, I think also only gives you the async API. So like a lot of the things we don't need async for yet. But later when I do the async, we will do the continuation passing style transformation of the code. I suppose. Yep. So async is actually not needed. The most complicated, the only feature that I think is not there in C that is in minicast is the closures, because I still want to have closures here, right? But I think maybe like converting the closure in like compiling that to C is not that difficult, right? But we can start with simple examples which don't use closures and just write the minicast for now, right? So that we can design the minicast before continuing to working on transpiling cast to minicast. You know what I mean? You start your fourth lang by attempting to convert async into state machines like in Rust. Right. Yeah, you can do like async by doing the state machines, or you can do the continuation passing instead, which is what I'm planning to do. This is like basically the two different implementations of the coroutines. One of them is stackless and one of them is stackful. And I don't know, like maybe eventually we will want the stackless coroutines too, but stackful is just easier for the user, I believe. And it can be pretty fast too, right? That's what Golang does, so yeah. But they do need a runtime, is the difference, right? But maybe we can like allow customizing the runtime still somehow. So like, is there any low-level language that does the stackful coroutines? Low-level language with stackful coroutines, where you could like basically replace the runtime. Your language can now somewhat correct call C libraries, and you have some sort of binding generator. Nice. Low-level languages with stackful coroutines, optional fibers, or green threads allow subroutines to suspend execution and stuff, right? Many modern low-level languages have opted for stackless coroutines for efficiency and memory projectability. Stackful coroutines are still available through built-in support or specialized libraries. For this new language, we are considering the limitations of Rust, OCaml, Gleam, and Kast. What's the limitation of Kast? Kast is limitless, right? Yeah, you have like the fibers in Rust. Anyway, I think it kind of does make sense to go this route then. I don't want to do today though, so let me. So okay. That was the old version that was too low level, I guess, and this would allow the minicast to be a little more high level. I want to store both versions though, right? Generic, then, right? Generic, low level. I don't know. Let's just revert this file. So we would be able to like compare these two things. Excessive type inference, which leads to slowness. No method support yet. Yeah, the type inference is not what leads to slowness, though, I think. But yeah, I'm considering that when I'm going to rewrite to do a little bit of a different version of the inference algorithm. We need something in the middle of the minicast and cast, I think. Maybe. There's also like the problem with the current inference in cast where we don't support the subtyping, but this over here would support the subtyping pretty easily. But it requires more type annotations for sure. Okay. Like din run type infon idea is what we have in this file. And this would like translate automatically to this other example, which already works. Yes. Okay, unless I change my mind, then next time we start working on the C backend, I guess. And yeah, even although I'm not sure if I don't know. Well, then I start the C backend, and we will like need to do everything in C. Will I even need the Golang backend then? I don't know. Can even consider cheating C. You mean like for the cast interpreter, I can like just in time transpile to cast, then transpile cast to C, and then JIT it? Or you mean like something else? Why would I JIT? Yeah. Yeah. Yeah, no, that's not going to happen until I self-host the cast fully, I think. Then we can think about things like jitting the interpreter and stuff. Alright, let's go for the anime tennis game.
3 times normal time. So that's how fast we rewind.
Thank you guys for watching. See you next time. Bye.